A firm is moving its intensive, high-performance computing workloads to Amazon EC2. The CloudOps engineer needs to select an EC2 placement group type to ensure the lowest possible network latency and the highest network bandwidth for inter-node communications. Which configuration is most suitable? Option A, utilize a cluster placement group within a single availability zone. Option B, utilize a partition placement group spanning 2 availability zones. Option C, utilize a partition placement group within a single availability zone. Option D, utilize a spread placement group spanning 2 availability zones. Okay, the correct answer here is option A, utilize a cluster placement group within a single availability zone. Let's understand why. Cluster placement groups offer the lowest possible network latency and the highest network bandwidth for inter-node communications. In order to achieve the lowest possible network latency and the highest network bandwidth, we need to ensure that all the workloads are within a single availability zone. Therefore, partition placement groups spanning 2 or 1 availability zones are automatically eliminated. Finally, a spread placement group spanning 2 availability zones would not fit this requirement. So, the correct answer here is option A. In cloud environments, placement groups influence how your instances are physically positioned across the underlying infrastructure. By organizing instances into specific group types, you can balance the need for high-speed network performance, fault tolerance, or isolation. When dealing with specialized workloads that demand rapid data transfer between nodes, the choice of group architecture becomes a critical factor in maintaining system efficiency and meeting application performance benchmarks. I believe the correct answer is option A. A cluster placement group is specifically engineered to deliver low latency and high throughput network performance. By placing instances in close physical proximity within a single availability zone, it optimizes the communication paths between nodes, which is the industry standard for high-performance computing applications requiring significant inter-node traffic. Regarding the other choices, partition placement groups are designed for large distributed workloads that require isolation from hardware failures by spreading instances across logical partitions rather than prioritizing raw network speed. Spread placement groups are used to place instances on distinct hardware to minimize the impact of correlated failures. This approach increases overall availability, but does not focus on network speed. For HPC, always prioritize the cluster placement strategy.